All right, today in class, we're going to be going over dilations. I'm sure you all have done dilations in a previous math class, but we're going to cover them again in geometry with a little bit different of a focus. So the very first thing that you need to know about dilations is that it's the only transformation where the size of your shape is changing. So it's either going to be an enlargement or a reduction based on your pre-image to your image. So if we look at this shaded triangle that was dilated to the non-shaded triangle, then we're gonna have an enlargement just because this shaded triangle is becoming larger to become that non-shaded triangle, okay? So we're gonna go ahead and label all the vertices of the pre-image and the image. Go ahead and pause the video and do this on your own. Okay, great, so hopefully you paused the video and you should be getting the coordinates that A is 2, 2. B is 1, -2, and that C is -2, 1. Then, if we look at the points of our image, we should be getting that A is actually 6, 6. B is 3, -6. And C is -6, 3. Okay? So now we want to kind of think about, okay, how are these coordinate points actually related from our pre-image to our image? So I want you to go ahead and talk in your table group about how you think that the x coordinates are related from the pre-image to the image. Go ahead and take a minute to do that. All right, now that you've taken that minute, okay, you can probably kind of tell that there's a pattern because if we take our A, B, and C coordinate from our x values and our new A, B, and C coordinates, you can actually get the image coordinates by multiplying the original coordinates by 3. So if I do 2 times 3, that's going to get me 6. If I do 1 times 3, that's going to get me 3. And if I do -2 times 3, that's going to get me that -6. That means that 3 is my scale factor for this image, so I scaled up my entire pre-image by 3. Okay, you can also find the scale factor by doing division, so I could have done like 6 divided by 2 and gotten the 3 as well. You just need to be careful that you're making sure that if you're getting larger, that your K value or your scale factor value is greater than 1. If you're getting smaller, your K value or scale factor should be less than 1. Okay, and if it stays the same, it would obviously be equal to 1. Okay, there's one other actually important thing about pre-images and images and dilations. So I'm going to go ahead and zoom into this graph and show you here. Okay, we dilate around the origin 0, 0. So if I make a ray from 0, 0 to each one of my points, it would look like this. When I dilate my shape, okay, all I'm doing is also technically like dilating that ray. So if I keep that ray going straight, it should still go through my image coordinates. So those lines should not be changing in slope at all, just the distance, which means that you could also enlarge your image by counting like over and down, however many times you enlarged your shape here. So like if I went over and down 2, if I do that 3 times, then I should be getting my image coordinate points. All right, go ahead and pause the video here and discuss with your partner at your table if you think that the y coordinates from the pre-image to the image will be the same as the x coordinate relationship or different. All right, now that you've done that, you probably noted as a group that it is actually going to be the same. The reason it's going to be the same is if you were to change how your x and y coordinates are related in a dilation, then the shape would actually change and not just the size. So if we're dilating our x coordinates by a certain amount, we have to do the same exact thing for y in order to keep our same shape. So if I have 2, -2, and 1 as my y values in my pre-image, then my image's values should also be 6, -6, and 3. Because if I multiplied all my left values by 3, I would get those right values. The same thing is true for the y portion of the coordinates when you draw those rays, right? That's why it's going through those perfectly. If something was off about our image, and one of these coordinates was not dilated by 3, then we would not be going through that point. All right, go ahead and take 2 or 3 minutes alone to fill out this next piece. So I want you to draw a triangle whose coordinates are twice the values of the corresponding coordinates of the shaded triangle. Okay, so instead of making our shaded triangle enlarged by 3, or a scale factor of 3, we're going to do it as twice as large. Pause now and go ahead and complete that process. All right, now that you've completed that process, let's fill it out together. So our original coordinates should be the same. It should be 2, 2, 1, negative 2, and negative 2, 1. Okay, when we're talking about our process, since our scale factor is twice as large, that would be a 2. So I need to multiply each piece of these by 2. So I write that like this. I'm going to do 2 times 2 for my x. I'm going to do 2 times 2 for my y. I will then do 2 times 1 for my x and 2 times negative 2 for my y. I will then do 2 times negative 2 for my x and 2 times 1 for my y. I should get that the image coordinates are 4, 4, 2, negative 4, negative 4, 2. You can always double check yourself by going back and just being like, okay, yes, negative 2 times 2 is indeed negative 4, so I would be right on that last value. Okay? So if we were to write an algebraic rule for dilating the scale factor by 2, that would be 2 times our x value and 2 times our y value, because that's what we just did in our process. But let's say we're trying to write this rule in general for algebraically, then we would want to kind of think, okay, well, I just need to manipulate my x and y value, and I'm multiplying that, like we can see here, by whatever my scale factor is. Well, up here, the scale factor is defined as k. So I'm going to say that kx, comma, ky is the general rule for dilating a shape. There's only one more thing we need to talk about before you can go on to your own practice. We're going to do it on the next page. Okay, let's go ahead and say that you're dilating by a negative scale factor. Okay, so I say, hey, I want you to dilate that shape by negative 3. You would almost want to think of this as k is negative 1 times 3, because your image will be getting 3 times larger, because this right here is greater than 1. However, when you multiply by this negative, it actually ends up rotating your image 180. Here's why. Our 180-degree transformation rule is that we have a negative x, comma, a negative y. Well, if I think about this and I was to just write this rule as a dilation rule, I would have negative 3x, comma, negative 3y. So no matter what, I'm already making each of my values flip signs or become negative from what they were previously and multiplying them by 3. So that means that if I had an image like this on my graph, when I dilate by negative 3, I'm going to end up with something like this. All right, that should be the last thing that we needed to talk about today before you complete your own practice. Go ahead and make sure that all of you have these notes written down from the video, and then you can get started with your task for the day.